It's loading.
I think I still see waiting for Inferless, yeah.
It's loading.
Okay.
Okay. Hi, everyone. Welcome to Inferless Live Town Hall. I'm Via Inferless Deborah, and today we are super excited to show you our brand new user interface. Joining me today are the co-founders Ashwarya and Nilesh. So, guys, want to say a hello? Want to say a hello and give us a quick introduction about yourself?
Hey, hi folks, I'm Aishwarya. I lead everything product and growth. Quickly about Infeless, we are basically building a serverless GPU inference for AI ML companies. So think of us as AWS Lambda, but for GPU workloads. And what we do is that we help companies deploy their custom and fine-tuned models with lowest cold starts in a serverless environment. Happy to be here.
Yeah. So hi, I am Nilesh. I'm the co-founder and CTO here. Before this, I have 10 years of experience in machine learning and infra. Currently at Inferless, we are building a serverless GPU platform. And again, the journey started with like when we were as a company trying to build an AI coaching bot. So during that journey, right, when we were trying to build that bot and sell to customers, there was no easy way to deploy models like GPT Neo or GPT-J at the time, and then it was super costly. So one of the solutions were that either we could take the EC2 machines and keep it always on. Uh, there was no such thing as AWS Lambda for GPUs at that time. And then when you even try to deploy a bigger model to CPU, it took like 5 to 10 minutes for the APIs to get started, which again was like deal breaker for us to deploy like machine learning models. So from that, the idea of Inferless actually sprung up that hey, like there should be a better tool for ML engineers to deploy machine learning models in a serverless fashion, where A, they had access to GPU compute, and B, they can start the APIs in like under 10 seconds. So these were the two main KPIs why we started like Inferless with. We spent the first year just solving these technical challenges. And from that, we went for a private beta launch. And yeah, today we are here with the next iteration of our UI.
Nice. Thank you for the introduction. AG will be with us in the chat right now, and Nilesh and I will take it from here. Today, we are going to walk you through why we made these changes and what's new. And then Nilesh will give us a live demo session. So we wrap up with some questions at the end, and get your questions ready for us to answer at the end of this live today. So thank you, Ash, for joining us. Let's take it over. So right now we are going to discuss why we made those changes. So why we revamp our full UI. Nilesh, can you share some insights on what prompt for this redesign?
Yeah. So again, when we built the first product, right, after like a year, the main 2 points were to like reduce the cold start and give developers access to GPU compute. While we solved for this, the first version of the tool that we made, right, it was really hard for developers to like deploy a new model. There were a lot of steps involved. The metrics and the logs were not that easy to access, right? So what we thought at that time was that developers would probably deploy a model once a month and then keep using it for the rest of the month. But what we learned in the journey, once 5 users actually deployed with us, that the deployment of model is a very continuous journey. Most of the companies that we work with deployed model every week, and some even deployed every 2 or 3 days. So for that, the developer experience for us to deploy machine learning models had to be super simple, where they can A, easily deploy models with lesser time, and B, they can also get feedback uh, pretty soon, right? Let's say if there's a build process we did not go through, the log should be comprehensive. They should have access to observability, like if the request latencies are going high, what is the reason for that? So these were the like some things that we learned from our initial set of users. And then that's how we went into deployment of the new UI that can help developers achieve most of these features.
Great. And I would love to know from you what's new, and can you walk us through the major improvements that we have been cooking lately?
Sure. Let me quickly share my screen, and then I can show you a quick walkthrough of the new platform. So yeah, this is how the Inferless dashboard looks now, right? So we have like a much more cleaner UI, which is very minimalistic, which focus more on the model. So the major things that we highlighted here was that we added the GPU type and like number of API calls ahead of like the UI card. So now you can see that, hey, which is the model version which is deployed. You can see when was the model last updated. Uh, and then we also have the card a little more flat, and then we have all the user options listed there. We also like made changes to the navigation bar where you can find all your CLI tokens, look at all your workspace metrics. I'll walk through them all in one, but this is the like first level where deploying a custom model is the main workflow that we have now highlighted. Other than that, we have also changed the model deployment process. So earlier it was a 5-step process to deploy a model. It involved a lot of choices and configurations which were not really required to deploy a simple model. So now to deploy a model, it's pretty simple. You can just simply click on add a model. Here rather than starting from what kind of model, we start from the provider where you want to start from. So let's say if you have a model on GitHub, Hugging Face, you can quickly start from there. You can directly select the integration and then just tell us about the model. So for this one, I'll just show you a GitHub-based model. So here I have a app.py, which has infer and initialize function. These are the two functions that you need to define to integrate with the Inferless functional interface. Once you have these set up, you can just like select GitHub and select the repository name. So this is Llama 2. It will list all your public and private repositories once you connect to it. So once you select the repository, it will automatically select the main branch for you. It will also give like a model name which is based on the repository, but you can feel free to edit it. Then we also set up CI/CD, where you can just like set up that, hey, whenever a new build happens, automatically build it. So this is a major change that we did. Then we also like removed the input output, where now you just write an input schema file and then it automatically configures that. Then we have made the selection of machines super easy. So we have we have 3 kinds of GPUs, and then we have made like option of fractional and dedicated, so you can easily select between them. And this is all you need to set up your GPU inference service, right? After this, you can deploy. We do have some advanced settings that we have also added. One of the things is like AWS private link. So with this, what you can do is basically it is interconnect between your AWS account and us, so the data does not leave the public cloud. This is something that we have also added, which is helps developers manage privacy and security. We have also added all the configs that you can change upfront rather than deploying and changing it later. So you can consider idle timeouts, inference timeout. You can also set up container concurrency upfront. So yeah, this is once you configure all of this, you can just click on continue. It's just a like 1-step process where it will quickly validate your model. And then once you have configured everything, and then you can just click on deploy and it start building the model endpoint. It takes like 3 to 5 minutes for the model to get built. So you'll probably come back to this. But once the model is built, you will see an API endpoint like this, where you have an API endpoint. So this is also a major part of our redesign, where we have put most of the information that developers need right up front. So in terms of like the machine status, you will be able to see what kind of machine you have deployed on, the number of API calls, what are the current running replicas. We have also added the card of like, so you can copy the curl and Python command directly from here. You don't need to go to the API page. The second thing that we have done in the API detail page is added a playground. So in playground, what you can do is you can directly like play around with the APIs over here, and then you'll get the output on the right side. So this is something that was earlier in a JSON mode, which was like a little bit cumbersome to read, but now we have a playground. Images, text, everything will come up here. Then we have also enhanced our logs and metrics. So logs are a lot more smoother now, where we have like collapsible logs for, let's say, if the log lines are bigger, you can expand them by clicking on these. We have also updated our metrics. Now we have like cold start, utilization, total number of API calls. You can also see like if there are errors being thrown by your APIs. Then we have also added a consumption tab, which will basically tell you like how much, if, like your which machine is consumed how much amount. So this is also something. These are some soft features that we have added for people to better manage their model. So yeah, that's a high level of how the new dashboard looks like. Yeah.
Awesome. And we also have a CLI way of deployment, right? And we will be coming up with that section soon. Um, that was awesome. And I think the whole process, it's a lot more fast and quick and very simple and visual looking. So that's really great. Like I saw both of the designs, and this one is really incredible. I'm so happy about this work. Thank you so much for giving us a demo about the product. Now we're gonna open up with some questions for the audience. So if you wanna ask a question for Nilesh, feel free to drop it in the live chat that we are going to be answering today. But I have a few questions for you right now, Nilesh. So the first question is, what kind of models do we support?
Yeah. So again, Inferless as a platform is completely like model agnostic. So if you see here itself, right, in the card, we have like a lot of different types of model. We have Llama, we have Park, which is a text-to-speech model. We have Stable Diffusion. So Inferless is really built with the architecture that we can support all types of model, whether it be like custom, fine-tuned, or OSS models, which are like long tail, which you want to deploy with us. Uh, yeah.
Great, great, great. And how is the deployment process for custom models? So we do it through GitHub, right?
Yeah, so there are again several options here. So we have made it like fully flexible and like however user wants it. So you can either like put your model weights on a S3 and then directly integrate with us. You can also write a functional interface on GitHub and deploy it to us. You can also write it to your local file and deploy it to us. So we also have a full-fledged CLI where what you can do is you can just like do a inferless, like you can just write this file in your local computer and then click on Inferless deploy, and it will basically deploy the model to Inferless.
Nice, awesome. Another question is, how are you reducing cold starts?
Got it. Yeah, no, so this is a question that we get asked a lot, right? So in terms of cold starts, I think there are like 3 to 4 strategies that we are doing to like reduce cold start. And it starts from the like load balancer level. So basically to reduce cold starts, we are making serverless more stateful. So for doing that, what we have to do is like the load balancer needs to be aware of the states where like each model are, or where the most of the weights or the container runtime for that model are. So that's the first part of the innovation where we have rebuilt our routing system and the load balancer. Second part of is really starting containers faster, right? So when it comes to like container starts, the biggest bottleneck there is like the Docker image pool. So in machine learning use cases, right, what we have seen is most of uh, the base libraries like CUDA and PyTorch and other libraries, those are same and used by multiple developers. So we compress them and like store them in a proprietary format so that we are able to boot these OCI containers super fast. And then the third is like we have a very active worm pool and auto scaling capabilities. So our auto scaler ahead of time predicts demand and then also say creates a worm pool for these customers. Now with this worm pool, all the API requests are able to boot super fast. Actually, what I can show you is we can just take a quick curl command, and this is a Llama 7B, I would say 16 gigabyte to 20 gigabyte model. So if you run a curl command on this, no, sorry, not this. Yeah, sorry, this one. I think this one's still building. Yeah, if we take a curl command, yeah, if we put time on this, yeah, so if you see the first boot of this takes around like 10 to 15 seconds. So this is where the model is booting up from cold. And then every other time we boot it, it takes like 3 to 4 seconds, right? That is where the normal inference is happening. So yeah, this should, yeah, so this took like 16.1 time to like put up. And then if we call it the next time, it just takes 3 to 4 seconds. So 10 to 12 seconds is roughly the cold start that we see here. Yeah. So that's about the cold start here. I can't hear you, Pia. I think you were on mute.
Great. I said, how secure is deploying with Inferless?
Yeah. So again, deploying with Inferless, we have like full container level isolation. We run gvisor and secure containers. Along with that, we are also ISO and SOC2 compliant. So we follow all security controls so that your models are safe with us. Then along with that, we also like have like security in terms of we encrypt your models and store them with us so that like even though if like there's a data leak, all your models are encrypted and no one gets access to your private files. So these are the three security controls that we have with us. And then also to like security is a super high concern, especially with the model and then the API request also. And to enhance that security, we are also working with like a lot of these cloud providers, and with AWS, we have this private link feature where let's say if you don't want the data to even leave, go to public cloud. So you can also set up a private link with us, and then it's just a secure connection between your AWS account and our AWS account. So you can consider that as we being a part of your cloud itself. Right? So that's how we're going about the security.
Great. Now going a little bit before around the code starts, can you show us like the process of the deployment again? Can you share your screen?
Sure. Is my screen not showing? When I was showing the code start, was my screen shared?
No, that's why I'm
Okay, okay.
coming back.
Okay, got it. Sorry, guys. I think I missed that part. I'll go for it again. So you were asking for the model deployment also again, right?
Yes.
Okay. Cool. I'll go about the how you can deploy a
Yes, I
machine
would
learning
love for
model
you
with.
to highlight around the low code starts and how can we get those low code starts?
Got it. Got it. Yeah. So how you can deploy a model with us is just like by clicking on add a model. Once you click on add a model, you can just select like let's say GitHub. Here you can just say, let's say I want to deploy a Llama 270 model. Once you do that, this is all the data we need. You can also optionally, we have like CI/CD with most of the integration providers. So you can set up CI/CD to be on. Then every time you push a code to main branch, it basically gets deployed. After that, we also have like the machine selection. So let's say if I want to deploy this on a A100, I can. We also have fractional GPU. So let's say if your model is like 40 GB and you don't need the complete A100 card, we can also give you a fractional A100 card. That's something that we uniquely have. Once you set this up, then there are some advanced configurations that you can do. Let's say adding custom runtime, which is like pip packages, configuring the timeouts. Once you have done all of this, you can just simply click on continue, and then it will quickly validate your model. And once you click on deploy, here in like less than 3 to 4 minutes, I have successfully deployed like a Llama 270 model. Yep.
Thank you so much for showing up again. The next question that I have for you is, can you please break down your pricing?
Sure, sure. So do you want me to run the cold start API again so that people can see that?
Yes, that would be incredible.
Sure. So I'll just do a time on this and paste the curl command. Once you see that once this API is booting for the first time, it would take around like 15 to 20 seconds. That will basically have 10 seconds of cold start and then 3 to 4 seconds of inference time. Uh, the next time we boot this, this will only take like 3 to 4 seconds. So if you see, it took like 16.48 seconds to boot the model. If I run this API again, then the inference time is just like 3.9 seconds. So 12 seconds was the roughly cold start that we have in our API. Yeah. So yeah, I think coming back to pricing, Bia, which you asked for. So in terms of pricing, we have a simple second base pricing. So basically, you only pay for the compute you use, and we have uh, prices for fraction and dedicated GPUs. Dedicated GPUs are somewhere let's say A10 goes for 1.22 and NVIDIA A100 is like $5.3. Now these might look a little bit higher prices, but the thing is that here you only pay for like what you use. So typically we see companies, right, that are, let's say, keeping the GPUs 24 on. We see them saving average between like 50 to 60%, and in some cases 80%, where their workload is, let's say, just 4 hours a day of compute. In most inferences use cases, right, you never use the GPU 24 into 7, right? The maximum you use is between 50 to 60%. So if you consider that, then with this, if you only pay for what you use, you automatically end up saving like 40 to 50%.
That's awesome. Thank you so much. And thank you all for joining today. That was a great session showing up our new revamp. I am so excited for everyone to try it out. And if you guys want to talk to us, reach out to us on Next. We have a community there, and we are there to help you and support you in deploying your models. Nilesh, any final words you want to say to the community before we wrap up?
No, yeah, I think just my final words would be, again, the idea with Inferless is just to help like accelerate way people like experiment with machine learning models. Since like machine learning model is a little different than compute, it's harder to, let's say, experiment with the Llama model than to change a Python code in your laptop. So we want developers to have the same velocity, quickly experiment with newer model, expand their like pipeline, and then also help them build like really great AI apps on top of us. Yeah. So we are really excited about the AI future and what people build.
Awesome. So we're very excited for you to experience this improvement. Thank you all so much for being part of the community, and we are all here to help you. Thanks for joining.